Imagine Earth embarking on a cosmic journey that places it as a moon, orbiting the gas giant Jupiter. This radical shift in our planet's orbit presents a mesmerizing opportunity to explore the profound implications on life, climate, and the solar system's dynamics. Setting the scene for Earth's transition into Jupiter's moon involves more than just repositioning. It's about understanding how such a shift redefines our world. The significance of this scenario lies in its potential to alter every aspect of earthly existence. As a moon of Jupiter, Earth would find itself far from the sun's life-giving warmth, dramatically impacting its climate. The distance increases by over 5 times compared to our current orbit, plunging Earth into a much colder environment and possibly leading to a planet encased in ice, akin to Europa or Callisto, Jupiter's existing icy moons. This chilling transformation challenges the very essence of life, adapting or perishing under extreme conditions. Consider how such a shift offers a real-world application in understanding climate change and planetary science. Scientists could study Earth's hypothetical adaptations to unearth insights into habitat resilience and innovation in sustainable living practices. Furthermore, this scenario serves as a parallel to efforts in astrobiology. By examining frozen environments on Earth, scientists extrapolate data to anticipate life's possibilities on other icy worlds, aiding in the search for extraterrestrial life. Opinions on this cosmic repositioning stem from the scientific fascination with the adaptability of life and planetary systems. Some experts argue that such a shift could spark unprecedented technological and biological advancements as humanity attempts to survive and thrive. This hypothetical scenario could foster innovations in space travel, habitat engineering, and energy utilization. However, several challenges and controversies accompany this concept. The primary challenge revolves around sustaining life in dramatically altered conditions. Adapting to a new light cycle, with Jupiter's eclipses casting frequent and lengthy shadows on Earth, would drastically change biological rhythms. Critics might argue that while scientifically stimulating, the feasibility of adjusting to such extreme transformations is beyond current human capability. This introductory concept ties into the broader topic by setting the foundation for exploring Earth's interactions with Jupiter and its new place in the solar system's gravitational ballet. It influences discussions on the Jovian system's dynamics, Earth's potential new role in cosmic exploration, and examines the ripple effects on human survival and adaptation. By reimagining Earth's position in the cosmos, we gain a wider lens to view the potentialities and vulnerabilities of our planet's singular place in its celestial neighborhood. Jupiter is the largest planet in our solar system, a gas giant distinguished by its swirling clouds and iconic Great Red Spot. Orbiting this behemoth are over 79 known moons, each varying in size and characteristics. The concept of Earth becoming one of Jupiter's moons introduces a fascinating what-if scenario that challenges our understanding of planetary dynamics and life as we know it. This idea immediately prompts us to consider the significant gravitational influence Jupiter would exert, shaping everything from Earth's orbit to its geology and atmosphere. Understanding Jupiter and its moons is crucial for grasping the drastic changes Earth would undergo. Enceladus and Europa, two of Jupiter's notable moons, offer a glimpse into the possibilities of life on a celestial body dominated by a larger planet. Europa's icy surface, for instance, suggests a subsurface ocean that could harbor life, while volcanic activity on Io, another of Jupiter's moons, exemplifies how gravitational forces can drive geologic activity. These moons illustrate how a life-supporting planet like Earth might transform when subjected to Jupiter's immense gravitational pull, potentially altering tides, volcanic activity, and climate systems. Opinions supporting this concept often highlight the unparalleled scientific opportunities, hypothesizing that close proximity to Jupiter could advance our understanding of planetary science, astrophysics, and possibly even the limits of life in extreme conditions. Enthusiasts argue that such a scenario could encourage us to innovate in ways to detect and adapt to changes in environment and biodiversity, ushering in new technologies and survival strategies. However, the prospect of Earth becoming a moon of Jupiter isn't without controversy or challenges. Critics point out that the transition itself could be catastrophic, possibly destabilizing Earth's axis or displacing its orbit, with dire repercussions for all life forms. The extreme radiation from Jupiter's magnetosphere could render the planet uninhabitable, raising questions about the longevity of life. Furthermore, differing opinions exist on our ability to adapt to such a radically altered environment. The exploration of this concept connects to broader questions about the resilience of Earth's ecosystems and humanity's adaptability in the face of dramatic changes. It underscores the delicate balance required for life to thrive and how dependent we are on Earth's current orbital configuration. In considering the possibilities, we unlock new perspectives on planetary habitability and reinforce the significance of our position in the cosmos, ultimately inspiring deeper introspection and appreciation for our home planet. When considering the hypothetical scenario of Earth becoming a moon of Jupiter, the effects on Earth's gravitational dynamics are both profound and complex. Gravitational dynamics refer to the interactions and effects of gravitational forces between celestial bodies. If Earth were positioned as a moon of Jupiter, the gravitational interplay between these massive bodies would drastically alter our planet's orbit, rotation, and tidal patterns. The significance of Earth's gravitational dynamics in this context cannot be overstated. As a moon of Jupiter, Earth's orbit would shift dramatically. Currently, Earth orbits the Sun, which provides a stable gravitational environment essential for maintaining our climate, seasons, and day-night cycle. However, while orbiting Jupiter, these foundational elements would change unpredictably, leading to significant alterations in our environment. For instance, the gravitational pull from Jupiter, which is more than 300 times the mass of Earth, could cause extreme tidal forces. These forces would result in severe geological disturbances, such as heightened volcanic activity and earthquakes. Additionally, Earth's rotation might be affected, potentially slowing down or becoming synchronous with its orbit around Jupiter, which would drastically alter the length of a day and affect life as we know it. In real-world applications, the principles of gravitational dynamics are crucial in space exploration and satellite deployment. For example, understanding gravitational dynamics allows NASA to effectively send missions to distant planets, utilizing gravity assist to increase spacecraft speed. Similarly, satellite orbit predictions depend on precise calculations of gravitational forces to ensure they function correctly and serve their intended purpose on Earth. Experts in astrophysics may hold differing views on the outcomes of such a dramatic gravitational shift. While some posit that Earth could stabilize in a new orbit, adapting over eons, others argue that the immediate effects would be catastrophic, disrupting the climate and biosphere instantaneously. Challenges to this idea lie in comprehending the sheer scale of Jupiter's influence and the unpredictability of Earth's new gravitational interactions. The potential of being captured by another celestial body's orbit introduces a host of unknown variables, which could lead to considerable debate among scientists. This discussion on gravitational dynamics not only highlights the potential changes to Earth's immediate environment, but also impacts other aspects like climate systems, ecological balance, and even the potential for sustaining life. Understanding these dynamics is crucial to appreciating the broader implications of our hypothetical journey to become Jupiter's moon, illustrating the intricate and delicate balance of forces that sustain our planet's current state. If Earth became a moon of Jupiter, the impacts on its climate and ecosystems would be profound and transformative. The Earth's climate is delicately balanced, affected by its position in the solar system, its atmosphere, and its interactions with the Sun. As a moon of Jupiter, Earth would be much farther from the Sun, receiving significantly less solar radiation. This drastic reduction in solar energy could plunge the planet into a deep freeze, vastly altering climates across the globe. Ecosystems, which have evolved over millions of years in response to the current climate, would face extreme challenges, potentially leading to mass extinctions or forcing dramatic adaptations. The significance of this point lies in the fundamental changes to life as we know it. Earth's position and climate are key factors that allow for a habitable environment. Changes in these factors would directly influence the planet's ability to support its current forms of life. For instance, photosynthesis, the critical process by which plants produce energy, would be severely affected by reduced sunlight, leading to potential collapses in food chains. This concept underscores the delicate interdependence between Earth's position in the solar system, its climate, and the ecosystems it supports. Real-world applications of understanding this phenomenon can be seen in climate change studies and astrobiology. For instance, as scientists study the potential impacts of climate change on Earth, they look at various climatic shifts that might mimic some of the extreme conditions Earth would face near Jupiter. Additionally, in astrobiology, understanding how life could potentially adapt to extreme environments informs the search for life on moons that orbit the giant gas planets in our solar system, such as Europa or Titan. There's considerable scientific consensus regarding the potential impacts of such a positional shift in Earth's orbit, emphasizing the importance of conditions within the habitable zone for sustaining life. However, exploring such a scenario also brings challenges and controversy, particularly concerning the ability of Earth's life forms to adapt or the ethical implications of encouraging or engineering such adaptations. In addressing these impacts, this topic connects deeply to other aspects of the video script, such as the potential for human adaptation or survival strategies. It raises questions about how humanity might engineer technology or energy sources to compensate for the loss of sunlight, or how we might preserve biodiversity. By examining these critical issues, the audience gains a comprehensive understanding of the broader implications of Earth becoming a moon of Jupiter, fostering a deeper appreciation of Earth's current position and the delicate balance that sustains life.